Regular movement of a mass of water in fairly well-defined direction over great distances is known as currents. Ocean currents can be compared with rivers on the land. So, ocean currents are large masses of surface water that circulate in regular patterns around the ocean. For example, North Atlantic Drift, Labrador Current, these are some examples of ocean currents. On the basis of temperature, there are two types of ocean currents, the warm ocean currents and the cold ocean currents. The warm ocean currents are those that flow from lower latitudes in the tropical zone towards the higher latitudes in the temperate and subpolar zones. They bring warm water into the cold water areas, and so they have a warming effect. So in this slide you can see the red arrows, they represent the warm current. They move from the lower latitudes towards the higher latitudes in both the hemispheres. The cold ocean currents, these currents have lower surface temperature and bring cold water into the warm water areas. They flow in the high latitudes from polar regions towards the lower latitudes in the warm equatorial region. So these blue arrows which you can see in the slide, they are moving from the higher latitudes towards the lower latitudes. Now let us see the causes of ocean currents. The origin and nature of the movement of the currents are related to the following factors. The first is the level of salinity. Water having higher salinity is heavier and it sinks or subsides. As a result, light water with less salinity rushes towards the area of high salinity and a current is formed. To maintain the balance, an undercurrent of high salinity water, which is much more dense, moves towards the area of lower salinity. For example, the water of Mediterranean Sea is more saline than that of the Atlantic Ocean. This results in the flow of a surface current from the Atlantic towards the Mediterranean and an undercurrent from the Mediterranean towards the Atlantic. The next factor is the temperature differences. At the equator, the temperature is high and it is lower at the pole. The equatorial water becomes lighter on heating, while water in the polar areas becomes heavy due to cooling. The warm light air floats and the warm light water floats and the cool heavy water sinks. This makes a difference in the level of the sea. To maintain the balance, the water from the equatorial areas moves towards the polar areas in the form of currents. To counter this, polar currents flow towards the equator under the surface. The third factor is the rotation of the earth, and you can see the picture also. Since the speed of rotation of the earth is maximum at the equator, all the moving bodies move in a clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere. For example, the Canary Current and the Gulf Stream in northern hemisphere and Peruvian and west wind drift in the southern hemisphere. Similarly, the prevailing winds also influence the ocean currents more than any other single factor. These winds blow consistently in a particular direction and drag the surface water due to the force of friction, which leads to the formation of ocean currents. Within the tropics, there are trade winds blowing from the east. They are responsible for north equatorial and south equatorial currents flowing from east to west. The temperate lands are under the influence of westerlies and the ocean currents flow from west to east. So, in your book, children, on page 85, the examples are all given. You must learn these examples. For example, the northeast trade winds move the north equatorial current to warm the eastern coast of Japan as the Kuroshio current. The southeast trade winds drive the south equatorial current, which warms the eastern coast of Australia as the warm East Australian current. Similarly, the westerlies force the warm Gulf Stream to the western coast of Europe as the North Atlantic Drift. They cause the cold west wind drift to flow towards the equator and the Peru Current along South America and the Benguela Current along South Africa. Monsoons also have a great influence. The strongest influence of prevailing winds on flow of current is seen in the North Indian Ocean. Due to the monsoon winds, which reverse their direction during summer and winter season, the ocean currents also change their direction from southwest in the summer to northeast in the winter. And the last factor is land. Landmass obstructs the flow of water of an ocean current and diverts its movement. For example, at Cape Sao Road, the South Equatorial Current gets divided into two branches. One joins North Equatorial Current and the other becomes the Brazil Current. So basically what it means is that when there is a landmass in the path of the ocean current, then it influences or it causes diversion in the flow of ocean currents. Now we will do some of the important ocean currents. So a very important ocean current of the Atlantic Ocean is the Gulf Stream. The Gulf Stream originates in the Gulf of Mexico and it receives plenty of warm water from the Gulf of Mexico and it carries it to the cold areas. So it exits through the Strait of Florida. As you can see in the map, you can see the Gulf of Mexico. We have marked it also. So it exits from the Strait of Florida and follows the eastern coastline of United States and Newfoundland before crossing the Atlantic Ocean. At about 30° west, 40° north, it splits into two, with the northern stream crossing to northern Europe and the southern stream recirculating off West Africa. The Gulf Stream greatly influences the climate of the east coast of North America from Florida to Newfoundland. So it has a very warming influence on the climate of these areas. And its extension, that is the North Atlantic Drift, that also greatly influences the climate of Western Europe, and Northern Europe is warmer than it would otherwise be because of the North Atlantic Drift, one of the branches from the tail of Gulf Stream. Now, because of the Gulf Stream, it has resulted in the development of strong cyclones in this area. So children, the Gulf Stream, it's a very important ocean current of the North Atlantic Ocean, and it has a warming influence because it carries warm water. So obviously the air above it is also warm. So it has a warming influence on the climate of the coastal areas. The next important ocean current, as you can see in the map and you can see it in your textbook also, is the Labrador Current, which has been shown with a blue arrow. It is a cold ocean current in the North Atlantic Ocean and it flows from the Arctic Ocean. So you all know that the cold ocean currents flow from the polar area. So obviously it carries cold water along with it. So it flows from the Arctic Ocean south along the coast of Labrador, which you can see in the map, and passes around Newfoundland, continuing along the east coast of Nova Scotia. It is a continuation of the West Greenland Current and the Baffin Island Current. Now both warm Gulf Stream and the Labrador Current, they meet at the Grand Banks southeast of the Newfoundland. The combination of these two currents produces heavy fog, which has greatly disrupted navigation in the past, and because of the meeting of the warm and the cold ocean currents, it creates a rich fishing ground because it helps in the growth of planktons, which is the food of fish. So this area, the Grand Banks, is known for fishing because of the meeting of the warm Gulf Stream and the cold Labrador Current. Now in spring and early summer, when the temperature starts to rise, this current, meaning the Labrador Current, it carries icebergs also, some chunks of icebergs along with it from the glaciers of Greenland into the transatlantic shipping lanes. So sometimes it becomes an hazard. The water of the Labrador Current, obviously because it is coming from the Arctic Ocean, it has a cooling effect. It lowers the temperature of the Canadian Atlantic provinces and coastal New England. Another important ocean current of the Atlantic Ocean is the North Atlantic Drift, which is actually an extension or a branch of the Gulf Stream. So you can see it in the map also. The Gulf Stream, in fact, the warm Gulf Stream is deflected towards the east under the influence of the westerlies and the rotation of the Earth, and it reaches Europe as the North Atlantic Drift. So, as it is a warm current, it keeps the ports of Europe free from ice even during the winter. Now, this current flows in three directions: eastwards to UK, as you can see in the map, northwards to the Arctic region, and southwards along the Spanish coast as the cool Canaries current. So, this is the circulation pattern of the North Atlantic Drift.